So we've Googled around a little bit and we found that we can usually find the stuff we're looking for. So let's go back and have a look at how we can do a better job maybe calculating some of these means. So I was able to pull off the time and the temperature from the first column of temperatures here, and I could plot it out, and I could get the mean of the first column of temperatures, and I could get the standard deviation of the first column of temperatures. But we've got 6 columns of temperatures here. So we'd like to be able to maybe calculate all of them at once. So what's the first thing that comes to mind? Well, a for loop would make sense. So for, lowercase f, I in range from 0 up to, well, no, we don't want to start at 0. We want to start at 1 because we're interested in the first column. For I in range from 1 up to 6. Is that going to be right? Well, let's check it out and see what we get. Print B of, let's just look at row 1, and we'll get the I value from that one. So that's going to print a whole series of them there. Now let's see what happens here. Oh, I only got 5 values. That's because it's going from 1 up to but not including 6. So I better make that 7. That should get all of them. Okay, so my for loop, I can go all the way across and get all of them as it goes across. 24.775, 26.526. That's 24.775, 26.526, and so on across there. So that matches up. So I got all of them that way. Maybe I should have started at column or at row 0 because I already got rid of the text stuff. So that's the first row, 24.854. Yeah, that's the first row. So that's good. Now, if I wanted to get the mean of each of those things, I could print the mean of, well, I don't just want the first row, I want all the rows, but only the I values of it. So there we go. Close that up. And I need to remember that's an NP function. So if I run that, what do I get? Those look like numbers that are believable. Average values that are different depending on which sensor we've got. And I could do the same thing Let's make the tabs line up because remember in Python it's the tabs that tell us that indenting is what tells us what's inside the for loop. So I get the standard deviations as well. In fact, why don't we put those together into a single print statement so that they're side by side with each other. So I'll just put a comma on that inside the print. And what do we get? Oh, sure enough, we get a bunch of believable numbers here. So there I've got some means and some standard deviations. What if I wanted to put them in an array of their own? Well, I'd need an array to put them in. So let's make an array and let's call it M. And for now, I'll just fill it with zeros. And I need 6 of them. And I need S also to be an array of zeros, and I need 6 of them. So then as I go down for I in the range from 1 to 7, I'm going to just have the 6 temperatures here, so I'm going to have to change that to a 0. So let's just try that out. M, the I value of M, oh no, I want it to start at 0, so I minus 1 value of M, I'll set equal to the mean calculation we did before. Whoops. And then I'll do the same thing for the standard deviation. This cutting and pasting is tricky stuff. So I'll do S, and I'll make it the standard deviation of the same stuff. And if I run that, I still print out the same things that I got before from this print statement. Let's get rid of that print statement. And now I'll print M, and then I'll print S, stretch that out a little bit more so that we can see what it looks like. Oh, I probably didn't want to print it as I went through the loop, but we can see this pretty clearly what's going on as we go through the loop. First it's calculating the first one and printing out the whole lot of them, and then it's calculating the second one and printing out the whole lot of them, then it's calculating the third one and printing out the whole lot. But we'd probably like that to be back here outside the for loop, so it only prints it out when it's finished doing the calculation. And sure enough, there we go, 25, 26, 25, 26, and so on, and 0.15. So now we've got 2 arrays of means and standard deviations. And if we really wanted to, we could print out the standard deviation of the mean, M, and I've only got 6 things now, so I better use that degrees of freedom setting to recognize that I've only got 5 degrees of freedom, so it'll use the n-1 carefully. Up here I really haven't cared because 40,000 or 40,000 minus 1 still going to give me about the same answer. So there we go. I've got mean, standard deviation, I've got for each of the ones, and I've got a standard deviation in the means of about 1.2. So there's a fair bit of variation in those mean values. And that's kind of cool. So I hope that points you along the way to getting the individual assignment 2 done. What else do we need to do in that assignment? Well, you need to make some sense out of those means and standard deviations. So you'll need to actually interpret these numbers. And I would really like to see you make some sense out of those and concentrate on the numbers rather than worrying too much about the Python programming. So we walked through the Python programming here, and I'm going to keep on giving you the part that has to take apart the arrays so that at least for the first little while you can focus on these numbers.